Okay, in the last class, we discussed about the properties, right? Properties of DFT. Those are linearity property. It will be proved, and a periodicity property. So it is also proved. Then third property, circular time shift, is also proved. And then we are going to discuss about the remaining properties. Those are time reversal property. Fourth property is time reversal property. Okay. So time reversal property of DFT says that reversing the n-point sequence in time is equivalent to reversing the DFT sequence. Okay, reversing the DFT sequence. Okay, reversing the DFT sequence. See, that is, if DFT of discrete Fourier transform of x of n equal to x of k, then DFT of x of n minus n is equal to capital X of n minus k. This is the time reversal property. So DFT of x of n is x of k, then DFT of x of n minus n is equal to x of n minus k. Okay, so let us prove this. So DFT of x of n minus n is equal to sigma n equal to 0 to n minus 1 x of n minus n into e power minus j 2 pi kn by n. Okay, here let us consider, let m be n minus n. So n will become n minus m. Okay, minus n equal to m minus n, or n is equal to n minus m. So replace m by n minus m, or n minus n by m, and small n by n minus m. Okay, then this will become sigma m equal to 0 to n minus 1 x of m into e power minus j 2 pi k into n minus m by capital M, right? So it will be extracted like this. So x of m into e power minus j 2 pi k n by n into e power minus of j 2 pi k into minus m, that is plus by n. So here n and n gets cancelled, so that it will become x of m into sigma m equal to 0 to n minus 1 x of m into e power j 2 pi k n by n into e power j 2 pi k. This will become 1. Okay, since k is an integer, so it will become, its value is 1. So it will become x of m into e power j 2 pi km by n into 1, that is e pi j 2 pi km by n, it is equal to x of m into e power j 2 pi km by n into e power j power minus j 2 pi into m. It's since n is an integer. So here 1 will be written as e power minus j 2 pi into m, 2 pi into m. Here k is replaced by m, so that it is j 2 pi into m. So j 2 pi into m can be written as into n by n. So it is equal to e power j 2 pi km by n into e power minus j 2 pi m into n by n. So here e power minus j m by n can be taken as common, so that it will become n minus k. Finally, it is x of n minus k. Here, this 1 can be replaced by e power minus j 2 pi into m, right? E power minus j 2 pi into m. Since m is an integer, e power minus j 2 pi m is equal to 1. So this 1 can be replaced by e power minus j 2 pi m. Divide and multiply this by n. So n by n, so that will get x of n minus k. So this is a time reversal property of DFT. Next, coming to the next property, that is conjugation property. What is that? Conjugation property. Conjugation property. Conjugation property. Okay. So what is conjugation property? Conjugation property. Conjugation property is defined as, let x of n be a complex n-point discrete sequence and x star of n be its conjugate sequence. X star n is its complex, its conjugate sequence, right? X star n is its conjugate sequence. So let us prove this. That is nothing but DFT of x of n is equal to x of k. Then DFT of x star of n is equal to capital X star of n minus k. Okay, DFT of x of n equal to x of k. Then DFT of x star of n is x star of n minus k, right? So let us prove this. E power DFT of x star of n is equal to sigma n equal to 0 to n minus 1 x star of n and e power minus j 2 pi n k by n, right? So it can be written as sigma n equal to 0 to n minus 1 x of n into e power j 2 pi n k by n whole power star. Okay, conjugate star. Or we can write this as sigma n equal to 0 to n minus 1 x of n into e power j 2 pi n k by n into e power minus j 2 pi into 1 is there here. That 1 can be written as e power minus j 2 pi n. Okay, or we can is divided and multiplied by capital N here, so that it will become x of n into e power j 2 pi n k by n into e power minus j 2 pi n into capital N by n whole power star. Okay, so taking minus j 2 pi into n by n as common, so it will become n minus k. Okay, so x of n into e power minus j 2 pi n into n minus k by n whole to the power of star, so that this entire thing will become x of n minus k whole to the star, or we can write this as x star of n minus k. So this is conjugation property. So DFT of x of n is x of k, then DFT of x star of n will become capital X star of n minus k will be proved. Next property is a circular frequency shift. What is that? Circular frequency shift. So the circular frequency property of DFT says that if a discrete time signal is multiplied by e power j 2 pi mn by n, its DFT is circularly shifted by m units. Okay, if the discrete time signal is multiplied by e power j 2 pi into mn by n, its DFT is circularly shifted by m units. That is, if DFT of x of n is equal to x of k, then DFT of x of n into e power, it will be multiplied by the discrete time signal is multiplied by e power j 2 pi mn by n. X of n into e power j 2 pi mn by n will become x of k minus m. Okay, let it be proved. DFT of x of n into e power j 2 pi mn by n is equal sigma n equal 0 to n minus 1 x of n into e power j 2 pi mn by n into e power minus j 2 pi n into k by n. So e minus j 2 pi n by n will be taken as a common. It will become k minus m. Okay, so it will become sigma n equal 0 to n minus 1 x of n into e power minus j 2 pi n into k minus m by n, or it will become, it is nothing but x of k minus m, capital X of k minus m, right? So this is the circular frequency shift property, and it will be proved. Next property is multiplication property. Okay, so as we already know that the multiplication in time domain will become uh, no, convolution in time domain will become simple multiplication in frequency domain. Okay, but here we are taking the multiplication, it will become simple convolution, right? So the multiplication property of DFT says that the DFT of product of two discrete time sequences is equivalent to circular convolution of the DFTs of the individual sequences scaled by a factor 1 by n. So simply the multiplication in DFT sequence will become circular convolution. Okay, and is scaled by a factor 1 by n. So that is expressed mathematically as DFT of if DFT of x of n equal to x of k, then DFT of x1 of n into x2 of n multiplication is equal to scaled factor 1 by n into x1 of k convoluted with x2 of k. So let it be proved. So by the definition of the inverse DFT, x1 of n is equal to 1 by n sigma k equal to 0 to n minus 1 x1 of k into e power j 2 pi n k by n, let k equal to m, so that it will become 1 by n into m equal to 0 to n minus 1 x1 of m into e power j 2 pi nm by n. Okay, so by the definition of DFT, the DFT of x1 of n multiplied by x2 of n is equal to sigma n equal to 0 to n minus 1 x1 of n into x2 of n into e power minus j 2 pi n k by n. But what is x1 of n? That is 1 by n into m equal to 0 to n minus 1 x1 of m into e power j nm by n into, let it be x2 of n will be let it be same, x2 of n into e power minus j 2 pi kn by n, right? Now rearranging the order of summation. Order of summation, then it will become 1 by n sigma m equal to 0 to n minus 1 x1 of m into sigma n equal to 0 to n minus 1 x2 of n into e power minus j 2 pi kn by n into e power j 2 pi nm by n. Okay, so 2 pi j minus j 2 pi into n by n will be common, so k into k minus n, so that it will become 1 by n into sigma m equal to 0 to n minus 1 x1 of m into sigma n equal to 0 to n minus 1 x2 of n into e power minus j 2 pi n into k minus m by capital N. Okay, so it is x1 of m into this is nothing but x2 of k minus m. Okay, so this is nothing but the convolution property, x1 of m into x2 of k minus m. So it is nothing but 1 by n into x1 of k circularly convolved with x2 of k. This is the multiplication property. Multiplication in time domain will become simple convolution in frequency domain. Okay, so this is the multiplication property, and hence it will be proved. Then eighth property is a circular convolution. Circular convolution. So it is defined like this: the circular convolution of two n-point sequences x1 of n and x2 of n is defined as x1 of n circularly convolved with x2 of n is equal to sigma n equal to 0 to n minus 1 x1 of m into x2 of n minus m. The convolution property of DFT says that the DFT of circular convolution of two sequences is equivalent to product of the individual DFTs, right? So let us let DFT of discrete Fourier transform of x1 of n equal to x1 of k and discrete Fourier transform of x2 of n equal to x2 of k. Then by convolution property, DFT of x1 of n convolved with x2 of n will become simple multiplication, that is x1 of k into x2 of k. So let x1 of n and x2 of the n-point sequences DFT x1 of k is equal to sigma n equal to 0 to n minus 1 x1 of n into e power minus j 2 pi n k by n, where k equal to 0 to n minus 1. So let n equal to m, so that it will become sigma n equal to m sigma n equal to 0 to n minus 1 x1 of m into e power minus j 2 pi n k by n. Similarly, x2 of k is sigma n equal to 0 to n minus 1 and x2 of n into e power minus j 2 pi n k by n, or let n equal to p, so that it will become x2 of p into e power minus j 2 pi pk by n, where k is varying from 0 to n minus 1, right? So consider the product x1 of k into x2 of k. The DFT of the product is given by DFT inverse DFT of x1 of k into x2 of k is equal to 1 by n into sigma k equal to 0 to n minus 1 x1 of k into x2 of k into e power plus j 2 pi n k by n. What is x1 of k? Already proved, m equal to 0 to n minus 1 x1 of m into e power minus j 2 pi n k by n, and here x2 of k is p equal to 0 to n minus 1 x2 of p into e power j 2 pi pk by n into e power plus j 2 pi nk by n, right? So it is 1 by n into sigma m equal to, now rearrange the order of the summation. So m equal to 0 to n minus 1 x1 of m into sigma p equal to 0 to n minus 1 into x2 of p into sigma k equal to 0 to n minus 1 e power j 2 pi k into n minus m minus p by n. Let it be considered as equation number 1. Okay, so consider the summation sigma k equal to 0 to n minus 1 e power j 2 pi k into n minus m minus p by n in equation 1. So let n minus m minus p be qn, where q is an integer. Okay, so will become qn by n, or n and n gets cancelled, so it will become e power j 2 pi k 2 pi into q 2 pi k q. So its value is 1. Since p is an integer, its value is 1. So sigma k equal to 0 to n minus 1 e power j 2 pi k into qn by n. Okay, qn by n. So n gets cancelled, e power j 2 pi q into k. So it is 1, e power j 2 pi q is 1 whole power k. 1 whole power k is equal to n. Okay, let it be considered as equation number 2. Consider the summation sigma p equal to 0 to n minus 1 x2 of p into x2 of p in equation number 1. So since n minus p is equal to qn, then p equal to n minus m minus qn. Okay, so sigma p equal to 0 to n minus 1 x2 of p is equal to sigma x2 of sigma n equal 0 to n minus 1 x2 of n minus m minus qn, or x2 of n minus m, sigma n equal 0 to n minus 1 x2 of n minus n comma mod n, or it is sigma m equal 0 to n minus 1 x2 of n minus n. Let it be considered as equation number 3. Using equations 2 and 3, equation 1 can be written as DFT, inverse DFT of x1 of k into x2 of k is equal to 1 by n into sigma m equal 0 to n minus 1 x1 of m into sigma n equal 0 to n minus 1 x2 of n minus m mod n. Okay, so sigma m equal 0 to n minus 1 x1 of m into x2 of, this is x2 of n minus m. Here n and n gets cancelled. Okay, and gets cancelled. So this is nothing but x1 of n circularly converted with x2 of n, so that the product of x1 of n and x2 of k is equal to DFT of the discrete Fourier transform of x1 of n circularly converted with x2 of n. Okay, this is about the circular convolution property. Okay, circular convolution property. Next property is circular correlation property. What is that? Circular correlation property. Circular correlation property. So the circular correlation of two sequences x1 of n and y of n is defined as correlation r bar of rxy of r bar xy of m is equal to sigma n equal to 0 to n minus 1 x of n into y star of n minus m. Okay, x of n into y star of n minus m. Right, let DFT of x of n be x of k and DFT of y of n be y of k. Then by correlation property, DFT of r star xy of m is equal to DFT of sigma n equal to 0 to n minus 1 x of n into y star of n minus m. Okay, so DFT of r bar xy rxy bar of m is equal to DFT of sigma n equal to 0 to n minus 1 x of n into y star of n minus m, or it is nothing but x of k into y star of k. Okay, let x of n, y of n be n point sequences. Now by definition of DFT, x of k is equal to sigma n equal to 0 to n minus 1 x of n e power minus j 2 pi n k by n, where k is varying from 0 to n minus 1. That is equation number 1. Similarly, y of k equal to sigma n equal to 0 to n minus 1 y of n into e power minus j 2 pi n k by n. Okay, let n be p, so it will become sigma p equal to 0 to n minus 1 y of p into e power minus j 2 pi pk by n, or k is varying from 0 to n minus 1. That is equation number 2. Okay, consider the product x of k into y star of k. The inverse DFT of the product is given by inverse DFT of x of k into y star of k is equal to 1 by n into sigma k equal to 0 to n minus 1 x of k into y star of k into e power plus j 2 pi n k by n. Okay, let n equal to m, so that it will become 1 by n into sigma k equal to 0 to n minus 1 x of k into y star of k into e power j 2 pi m k by n. Right, so it is equal to already x of k, y star of k values are there. So it will become 1 by n into sigma k equal to 0 to n minus 1 sigma n equal to 0 to n minus 1 x of n into e power minus j 2 pi n k by n, and sigma p equal to 0 to n minus 1 y of p into e power minus j 2 pi pk by n whole star. Why? Because it is y star of k whole star into e power j 2 pi mk by n, right? So that by interchanging the order of summation here, so that 1 by n sigma n equal to 0 to n minus 1 x of n into sigma p equal to 0 to n minus 1 y star of p into sigma k equal to 0 to n minus 1 e power j 2 pi k by n is common, and it is a m minus n plus p, m minus n plus p. Okay, consider the summation sigma k equal to 0 to n minus 1 e power j 2 pi k into m minus n plus p by n in equation number 3. So let m minus n plus p is equal to qn, where q is an integer, so that e power j 2 pi q will become 1, so that it will become e power j 2 pi k by n into m minus n plus p, or m minus n plus p is qn. So qn by q, so e power j 2 pi q is nothing but 1. So 1 power k, it is equal to n, that is equation number 4. Okay, so consider the summation sigma p equal to 0 to n minus 1 y star of p in equation number 3. So p equal to n minus n plus qn, so that it will become sigma p equal to 0 to n minus 1 y star of p is equal to sigma n equal to 0 to n minus 1 y star of n minus m plus qn, or it is equal to n minus m mod n. Okay, so it is y star of n minus n. Substitute this equation number 4 and 5 in equation number 3, so that it will become DFT of inverse DFT of x of k into y star of k is equal to 1 by n into sigma n equal to 0 to n minus 1 x of n into sigma n equal to 0 to n minus 1 y star of n minus n into n. So n and n gets cancelled. So sigma n equal to 0 to n minus 1 x of n into y star of n minus m. It is nothing but rx bar of m. So therefore x of k multiplied by y star of k is equal to discrete Fourier transform of rxy bar of n minus rxy bar of m. Okay, this is the property. That is what is that property? It is a circular correlation property. Okay, circular correlation property. Next one is Parseval's relation. Parseval's relation. Parseval's relation. So how it is defined? Let DFT of x1 of n equal to x1 of k and DFT of x2 of n is equal to x2 of k. Then by Parseval's relation, how it is defined? Sigma n equal to 0 to n minus 1 x1 of n star x1 of n into x2 star of n is equal to 1 by n into sigma k equal to 0 to n minus 1 x1 of k into x2 star of k, right? So sigma n equal to 0 to n minus 1 x1 of n into x2 star of n is equal to 1 by n into sigma k equal to 0 to n minus 1 x1 of k into x2 star of k. Okay, so let me prove. So let x1 of n and x2 of n be n point sequences. Now by definition of DFT of x1 of k is equal to sigma n equal to 0 to n minus 1 x1 of n into e power minus j 2 pi n k by n, where k is varying from 0 to n minus 1. Similarly, by the definition of inverse DFT, x2 of n is equal to 1 by n into sigma k equal to 0 to n minus 1 x2 of k into e power plus j 2 pi n k by n, right? Where n is varying from 0 to n minus 1. Okay. Then consider the RHS term of Parseval's relation, that is 1 by n into sigma k equal to 0 to n minus 1 x1 of k into x2 star of k is equal to 1 by n into sigma k equal to 0 to n minus 1. So sigma that is x1 of k is, what is x1 of k? Sigma n equal to 0 to n minus 1 x1 of n into e power minus j 2 pi n k by n into x2 star of k. Okay, x2 star of k, right? So by changing the order of summation, so sigma n equal to 0 to n minus 1 x1 of n into 1 by n sigma k equal to 0 to n minus 1 x2 star of k into e power minus j 2 pi nk by n, right? So it will become sigma n equal to 0 to n minus 1 x1 of n into 1 by n into sigma k equal to 0 to n minus 1 x2 of k into e power j2 by nk by n whole star. Okay, whole star, right? So it will become sigma n equal to 0 to n minus 1 x1 of n into x2 star of n, hence proved. So Parsel's relation states that DFT of x1 of n is x1 of k and DFT of x2 of n is x2 of k. Then by Parsel's relation, sigma n equal to 0 to n minus 1 x1 of n into x2 star of n is equal to 1 by n into sigma k equal to 0 to x1 of k 0 to n minus 1 x1 of k into x2 star of k. Hence it will be proved. So 1 by n into sigma k equal to 0 to n minus 1 x1 of k into x2 star of k is equal to sigma n equal to 0 to n minus 1 x1 of n into x2 star of n, right? So it is the Parsel's relation. Like that we have 10 properties of DFT. The first one is linearity property. Okay, linearity property was proved. Next one is periodicity property. Third one is circular time shift property. Fourth one is time reversal property. And fifth one is conjugation property. Okay. Sixth one is circular frequency shift. Seventh one is multiplication property. And eighth one is circular convolution property. Ninth one is circular correlation property. And last one is Parsel's theorem, right? Parsel's relation. These are very, very important properties of DFT. Okay, practice it. So all of you practice these properties. These are very important. So by practicing on paper only, we can learn. Okay. So by studying, we can't learn these properties. We can't learn any concept. By practicing it only, we can understand. Why? Because it is a problematic subject, right? Problematic and analytical subject it is. So that's why we have to practice on paper only. Okay, by studying we can't get the concept. Okay, by studying we can't get the concept. By practicing on paper only we can get the concept. So all of you practice on paper only. Okay, so that we can understand easily. Okay, in the next class we will discuss about the linear convolution. Okay, with this I'm concluding the today's class. So today we discussed about the properties of discrete Fourier transform. Okay. So in the next class we will discuss about the linear convolution. Okay. With this I am concluding the today's class. Thank you.